Welcome, everybody, and thank you for joining us. My name is Christina Caesar, and I will be moderating today's session. Usually we'd give everyone a minute to join, but I know Adrian has a lot of content he wants to cover today, so I'm just going to go ahead and kick things off. Today's webinar will explore conditional access as a post-authentication behavior. So I know this has been a huge topic in cybersecurity recently. As a point, Adrian has a lot of content to cover. Just a reminder that the session is being recorded, and please make sure to send any questions through the Q&A function within Teams. Just a little bit about us. Synergy Technical is an IT consulting firm headquartered in Richmond, Virginia. We have clients in over 70 countries and all 50 states and manage over 2 million licenses of Microsoft 365 for our clients for our licensing and managed services practice. In February of 2020, we were awarded the Microsoft 365 Security Deployment Partner of the Year award. 2 years later, that's still a mouthful. And a large part of that success is the work done by today's presenter, Adrian Amos. So Adrian is one of our best sales engineers and solution architects who has deep level experience in the Microsoft suite, both productivity and security, and who's had the honor of running customer immersion experience workshops at Microsoft Ignite for several years, as well as present at other conferences and expos across the country. So with that speedy and raving introduction, Adrian, I'll hand things over to you. If you want to start sharing your screen, we can kick this thing off.
Thank you so much, Christina. I'm going to do my best to hit share and not leave. Every once in a while, I hit the wrong button. And it's going to be exciting. All right, so let me know when you are able to see my screen, and I will continue.
Yep, we can see it. Go right ahead.
Fantastic. Thank you so much. All right, so we're going to be talking about conditional access today, right? And one of the biggest misconceptions about conditional access is where it falls in the Microsoft authentication journey, right? So what we need to do is we need to kind of set the stage of what an identity and access management solution is, how it should operate, what components it should enable, and then we'll step into the things that are made possible with conditional access policies, and we'll dig into it a little bit. We'll even get into a demo a little bit too. So we hosted a webinar last year, back in May, in which we discussed what comprises an identity and access management solution. That event was framed around the idea that Active Directory, going to be a long day. I'll get it right. Active Directory is a legacy identity product because it only handles authentication and not authorization. And it's time to make the shift to cloud-first identity, largely because of access management. And when I was preparing for that webinar last year, I spent a fair amount of time looking for a technology agnostic definition of identity and access management. And I ended up settling on a combination of these three statements here. IAMs in general support authentication and authorization and automation of business processes related to identity lifecycle management. And that still holds true, right? But I think we can safely color in some of these elements now. We have three main pillars, right? Authentication, authorization, and automation. And I'd argue that any solution that doesn't offer all three of these things in tandem in a single box is not a true identity and access management solution. We may be looking at an identity provider or an access broker or an automation engine, but without having all three of these things working in conjunction, it's not a true IAM. Azure AD is an IAM. In the left-hand column of authentication, we have the actual security principles and sign-in and the mechanisms for handling these processes, right? Whether it's password protections or MFA configuration or even the brokering of account data into thousands of integrated SaaS applications. So we've covered just about all of this stuff in previous events, and I'm sure we'll cover them more as these solutions continue to develop. But in the middle column, the stuff we're mostly focused on today, we have supplied a credential, right? Now we need to decide what to do with it. We trust that credential, right? Okay, great, it's valid, but do we really trust that it should have access into our systems? Maybe there's risk associated with that credential. What kind of access should that credential have beyond simple membership in groups? And because anybody can handle group memberships, and if that's all the security that's present in the environment, it really becomes a grand reshuffling of responsibility from the identity provider to the app or solution or the system owner to then manage access on their systems too. So we've kind of moved the priority of responsibility out of our bucket and put it in somebody else's bucket. With an IAM, we can actually bring some of that back in. On the right, we have the automation and orchestration components that typically set larger, more complex organizations apart with their identity needs. So we actually covered identity governance a few months ago, and it's one of the absolute standout capabilities of Azure AD that's available to any organization that has P2. Highly recommend taking a look at it, but we will circle back and address that in another event. But what we need to do is we need to understand that middle bucket, right? Azure Active Directory conditional access. So according to Microsoft's published documentation, Azure AD conditional access is, and I quote, at the heart of the new identity-driven control plane. And you've probably seen this image or one that's like it in the past to show all the awesome controls that are available. And this slide has a lot of data in it. It's a little bit outdated, right? Some of the outdated product names are in there, but the gist is still relevant. We evaluate a number of conditions, or what we'll call signals, assess against policies, and make decisions on whether or not to allow access, and if so, how much to our apps and data. The goal of our conditional access policies is to give us greater control over access to our data and should be considered a critical component of any modern identity and access management solution, right? We have to get away from the idea that I've authenticated you, now it's the app owner's problem to figure out how to protect the app. No, we need to take some level of responsibility for managing access to those apps. So we are using this as an augmentation to the existing app controls that may exist, right? It's not a replacement for them. We should not look at conditional access as saying, well, take your hands off the wheel, Exchange team, right? We've got this from here. This should be considered an augmentation or an additional step up set of controls that we can leverage that can then also, in many cases, be recycled and taken to other workloads too, to make sure that everybody gets the same result. Now, I did mention, or actually I didn't mention, I should have said Azure Active Directory's conditional access policies are a component of Azure AD Premium. But this does not mean that you are unprotected or unable to leverage some of these controls if you are an Azure AD basic customers, right? So if you don't own Azure AD P1, you actually get what are considered security defaults in Azure AD. These are enabled by default, and they can be turned on or off with a simple switch in the Azure AD properties page, and they give you some baseline security controls like enabling MFA registration for all users, requiring MFA for admins. Even though MFA is an Azure AD premium capability, admins get it by default in free and basic tenants as well. So this actually goes and enables that requirement for those users. It blocks legacy authentication, so it turns off like POP3 and those authentication controls, and it enforces step-up MFA for some protected actions like logging into the Azure portal or protected consoles. So technically, these are actually conditional access policies, and they used to actually show up in the Azure conditional access portal as baseline policies a couple of years ago, but now they've been moved into this. Now, these can be turned off, right? And they have to be turned off in order to move to conditional access policies, but they don't go away on their own automatically. So when it's time to step up into Azure AD Premium licensing and start configuring conditional access policies, we have to go find this setting and turn it off. But before we turn it off, we really want to understand what these things are so that we can replicate this functionality in our conditional access policies. The good news is that Microsoft recently added the ability to deploy some baseline policies from templates. Though this is still technically in preview, it is the easiest way to transition away from the traditional, from the built-in security defaults, because if you go back to that original list, most of it is actually duplicated here. So this is a great starting point for, I've turned off my baseline or my defaults, I want to move into CA policies. You can pretty much just go through the list and turn most of these on. And there are also templated deployment options for devices as well. So everything on the previous page is identities, this is all devices. And by default, they're all going to go into report only mode, which is like a really souped up, super awesome version of what if, and we'll get into how that looks in a little bit too. And I highly recommend all policies be tested initially in report only mode. It's probably the best thing that's been added to conditional access since the dawn of time. Anyway, so let's talk about what these policies do, what they analyze, and how they can help determine access. At their most basic level, conditional access policies are just if-then statements. We use these if-then statements to look at signal data and make decisions, right? The first part of any conditional access assessment then becomes the examination of that signal data. What can we assess and what's the value of that data? We get a lot of signal data that comes with every single authentication, and some of it is presented pre-authentication, and some of it is only determined as a result of the combined factors of authentication. In general, pre-auth data isn't going to be as high fidelity as post-authentication data. So while we can use it in determining the resultant set of accesses, we may not want to actually base our authentication decisions on it. So let's take a look at some of the signals that we do have and assess the quality or the fidelity of those. So I tend to break down our signal data into low and high fidelity camps, right? Low fidelity signals are typically those presented as part of the initial authentication experience. They include attributes that can usually easily be forged or even omitted. First up is the source IP address, right? Unless that address is part of your trusted IP ranges, and then even then, maybe it's only slightly better than a public IP source, right? The problem with this attribute is it is super duper easy to forge or obscure. And while it is an instrumental part of creating our named locations, it's important to know that state actors, the ones that we're generally worried about trying to get into our systems, right, and that we want to block, they only reveal their actual source country IP addresses when they want you to know it's them attacking you. Right, so we can't really rely on this. And then, a lot of people who are coming from these nefarious considered locations, maybe tunneling through a VPN. And then there's other challenges too, like IPv6 addresses cannot be tied to a source. And then there's a whole host of IP addresses that just get tied to unknown source, right? So if we're trying to be super targeted around IP addresses, we have to trust that IP address data is correct, that it's accurate, and that it's reliable. And it just generally isn't. It's also important to know that globally, Microsoft tenants, all of them, use the same URL for authentication, and it's login.microsoftonline.com. And this and all the other necessary URLs and IP addresses for accessing Microsoft services are well documented, but it means that we can't tell Microsoft to just block authentication from our ITAR restricted countries, because Microsoft definitely has customers in those countries, and they definitely want to be able to log into their own environments. So this is part of why we assess these source IP addresses post-authentication. They're your preferences. They are not global data center requirements for Microsoft. Similarly, platform and browser data is all presented as part of the user agent string, and that data is all voluntary at best. When you point an unconfigured browser to a website, it will report what the browser is, the OS, the version it's installed on, in some cases, the screen resolution, and any host of any other attributes that can be used to custom tailor what the user's experience is going to be when they're on that website. And if you watched Last Week Tonight with John Oliver, he just did a whole big segment on data brokers and their use of that agent string content to help build profiling information around users. Super highly recommend. But in it, he talks about how easy it is for bad guys to forge that data, right? And it's true. And we can even just turn it off entirely. So Microsoft even includes this great big caveat in their documentation around conditional access policy, that just because you can get some of this data doesn't mean you should rely on it, right? In fact, the device platforms data that just recently got Linux introduced and got everybody all excited about, oh my gosh, Microsoft's going to support Linux in their CA policies. Well, you can see right here, it says specifically user agent strings can be modified. This information is unverified, right? So yes, it's there. Yes, you can do stuff with it, but again, it's an augmentation. Don't rely on that data or that setting to save your content, right? So we need to look at higher quality data, higher fidelity signals to make more informed decisions about access to our systems. That data is going to include attributes that are determined by an aggregation of current and prior knowledge about the requesting user and device. Is the device already managed? Is it compliant with our internal configuration requirements? Is it reported safe through our AV and our EDR solutions? And what about the group or the user that's requesting access? Do they hold an Azure AD role that should or shouldn't be able to access the app in question? Is their credential exposed on the internet and being used in other attack vectors? Again, there are other ways in Azure AD to exercise protections over roles and credential risks, but with those methods, it's all or nothing. Whereas with conditional access, we could allow someone who's at moderate risk overall to still access limited versions of our applications, maybe if they pass an MFA prompt, right? So we can keep our users productive without interfering with their day-to-day business, without having to create a help desk ticket, by simply enabling nuance through conditional access policies rather than sledgehammers with identity protection policies. But they can also work together. So I also included trusted IPs and GPS location data in the high fidelity section, not because it's determined by prior management efforts necessarily, but simply because it is in general more reliable than just device reported IP addresses. But even GPS data has some interesting limitations. The device itself has to be able to report it, and some devices are unable to do so. And this can cause access to fail even if the policy isn't actually enabled. So there are some known situations where a GPS-based policy simply existing can cause a situation where an application says, well, I can't query that data, and so I can't evaluate it, and so I can't even go through conditional access policy assessment. We don't want to get into that situation, so we need to understand how our applications leverage this data and how to protect it. But it's interesting too, because once we ask for GPS data, the device is going to be required to continually report that GPS data every hour for the next 24 hours, and then it'll go through a re-request. But if we have multiple policies that all request GPS data, we can actually have this machine throwing up hundreds of responses, right? So we want to be very cautious with how we layer our policies to make sure that we're requiring or requesting the right amount of GPS data if we're going to rely on that. So the point here is that not all high quality or high fidelity signal data is appropriate for all environments or all applications, and some low fidelity signal data can be incredibly relevant if it's simply more usable and provides better protection than none at all, right? We have to be aware that good enough or perfect can't be the enemy of good, right? We can't spend all of our time in analysis paralysis trying to find the exact right set of scenarios. We need to actually make sure that we're driving protections. And as admins, we then have to choose the signals that are right for us, for our users, and for our apps. So we also have the ability, this was recently introduced, and I love this, this is one of my favorite capabilities, is the ability to filter for devices for much more detailed attribute data about these devices, some of which falls into the high fidelity camp, and some of which can be determined for managed or unmanaged devices, right? So there's this great chart here that shows what's going to happen as a result of using some of these device filtering capabilities based on whether or not the device is managed or unmanaged. And this replaces last year's or the previous year's device state data, which could only assess compliance and whether or not a device was hybrid Azure AD joined, and could actually only be used in exclude mode, which meant you had to build your policies kind of the same way you built domain trusts, by thinking about the inverse of the problem and building to that and then hoping that it would work. We saw a lot of testing challenges with that, and it really just was a lot more complicated and tricky for implementation. These filters, though, can be used in include or exclude policies. They're created per policy, right? So each conditional access policy is going to have its own separate filter for devices. So they should not be confused with Endpoint Manager's device filters, which can then, which are discrete filters that can be recycled across configuration and compliance policies and all that kind of fun stuff. There is no way to use those filters in a conditional access policy. But this allows us to take a huge array of attributes that exist and are defined around each device and leverage attribute matching. And it's a great way to do much more granular control of access into our applications. And I'm a huge fan of layered approaches to conditional access policy. So I may use one set of policies based on, you know, some of the filters and capabilities here to make sure that only the right users from the right devices can access Windows 365 at all from the web. But then once they're in, they're not going to hit these policies. So I might choose the device display name, if it matches Cloud PC as a start, is not going to get hit by any of these policies. So it's a really great way to do some exercise and control here too. But the thing that I love most about the way Microsoft implemented these is that they're using dictionary of key value pairs. whenever possible to avoid having typos break enforcement. So for trust type, for device ownership, and for is compliant, once I choose that as the attribute and choose my operator, my value comes from a drop-down box that's pre-filled. So I don't have to worry about having to type Azure AD joined, right? And this is the kind of thing that has really been a challenge in some of the other management areas. We have to know our specific attribute values that we want to match against. Like if you're building a dynamic group, you have to get all the attributes typed in just exactly right. This is putting guardrails on that process, and it makes it a lot easier to drive the right results. So now we've got a lot of our signal data, right? Now it's time for us to make some decisions. And for that, we are going to flip over into our demo tenant, and demo gods be with me, right? So we're going to see about some of the things that we can do with conditional access policies, set some guardrails, and we're going to talk about some of the fun things that come with inclusions and exclusions and all kinds of here. So let me recycle because, of course, my demo tenant decided to expire itself. Get authenticated here, and here we go. All right, so these are my conditional access policies in my demo tenant. I don't have a whole lot of them, and you can see I created most of them last year. But at a baseline, right, we're going to come in, we're going to hit new policy, and we do have this new templates view that's here. But if I come in and I create a new policy from scratch, I have some things that I need to define. I'm going to define my users or workload identities that are going to be covered by this policy. I'm going to choose my apps and my actions. I'm going to choose my conditions, my grants, my sessions, and then I'm going to decide how I'm going to turn this thing on. For assignments, this is fantastic because we've always had the ability to do users, but now we also have the ability to add workload identities to this. So I can choose workload identities and I can look at service principals for inclusion or exclusion. And really super important thing to note here, whether we're doing users and groups or service principals or whatever, excludes always beat includes. Take a moment. Excludes always beat includes. So when we're building out our CA policies and we're concerned that we might break something, we always want to leave it a way back in, always put somebody in an exclude group. I'm a huge fan of doing like a break glass group or account or something like that. Anyway, we can decide whether we want this to affect our users and groups, and if so, which users and which groups. We can do guest users, so we can then bring in our B2B environments and make sure that our conditional access policies are equally applied to those. We can actually also say like global admins shouldn't be subjected to this. This is really cool stuff, right? Then we're going to come in and we're just going to say all users, and we're going to get this great don't lock yourself out notification. For cloud apps, we're going to choose the apps that we want to govern with this. And again, I'm like I said, my big thing is I want to make sure that Azure Virtual Desktop and Windows 365 are accessible from the right places for the right folks. And if I come down through the list, or even if I just search, you see Azure Virtual Desktop shows up there, as does Windows 365. I can just add these two to a single policy. These are my apps that are going to be governed by it, right? Then we're going to decide what our conditions are. And again, all of these things are things that we've talked about and looked at, but this is where our real signal data is going to be compiled, right? We've covered all that, but I'm going to jump into the grant controls. Now, we have some really interesting things that we can do with this, right? What kind of grant do we want to allow? Block is just block, right? That's it. Okay, game over, you're done. But if we're going to grant access, how much access do we want to grant? What is that going to look like? Are we going to require that if you get access into this application, you have to be using this pre-approved client app to do it? This is not the same as saying that you know, we're going to restrict access as signal data from client apps. This is going to say, well, what are we going to allow you to get into once you come in? We can enforce account protections, and this right here, this CCPA, we can actually take terms of service and throw them at our users too, and say, in order for you to get in, you have to have agreed to this terms of service. And what's cool here too is that if I have other things that are reliant on this, they can read the signal data from the sign-in log to see that the user has already agreed to the terms of service and let them right in without prompting them to do it again. So really cool stuff. And then we can decide whether or not we want these users to match all of these controls or just one. So I can come through, whoops, I clicked in the wrong place. I can click on multiple things, right? And I can say, well, if you hit any one of these, we're going to be able to do this as long as you just have at least one of these things done. And then we can also throw controls over the fence and allow our applications, whether they're Exchange Online or SharePoint Online or third-party applications with conditional access app control through Defender for Cloud Apps, to also take additional controls over what sort of stuff should be allowed. And what's really neat here too is if we just turn on conditional access app control with monitor only for these apps, what ends up happening is not only do we have a sign-in experience or a logged sign-in for the user going to this app in our Azure AD sign-ins, but we also get a record of everything they did in Defender for Cloud Apps as a tracked session. So we get logging in both sides, one that shows authentications, one that shows actions. So it's really nice capability there to augment. And then we can also do fun things like blocking downloads. And while this says it's in preview, we've been using it very reliably for several years to do all sorts of demos and fun stuff. We can allow the user to have a persistent browser session, right? We can do all this kind of other fun stuff too, and even disable resilience defaults, which I don't recommend. But we can get in here and we can control all of the things that the user is going to experience as part of this conditional access policy. And then again, we can turn it on in report only mode. And I do strongly recommend that. And I do not specifically recommend the what if button, because the what if is not actually what if, it's actually what now. This looks at what if the user, an existing user tried to sign in right now, what would their experience be? It's not like a PowerShell what if, where it's going to evaluate your conditions and say, this is what would happen. No, it's going to show you what's going to happen right now. Again, report only mode changes that. But we take our signals, right? I showed you that we can talk about our source IP addresses, and we can tie those to countries, and we can use that as, again, low fidelity data. We have the ability to create all of these different places, and we can configure our trusted IP addresses that allow us to, in the Azure AD space, bypass MFA. We can actually ingest those directly into our conditional access policies and also then name them so that we can identify if traffic is coming from, say, a corporate office versus a satellite office versus whatever. So we can get really granular with helping to keep track of who's being able to get to what stuff. And then we can upload our terms of use here too. Here's my CCPA capability, right? And now from inside this CCPA space, I can see, languages that exist in here. I can look at the actual thing. It's not really a CCPA thing. I've made a fake one, but we can also look at the audit logs too and see, are users actually engaging with my terms of use requirements? And this one's going to be super great when you're dealing with guests or people who are doing like BYOD kind of thing, right? Enabling the terms of use in a way that doesn't do the when log on experience where they have to agree to a thing before they get the interstitial before they log in. Yeah, we're done with that. We can just do that at the app workload. So those are the controls that we have, right? And when we enable these controls, again, we're able to pull in content from identity protection, which is looking at, again, whether the credential pair is at risk out on the internet. We can consume data from, whether or not users have these privileged identities, they're role holders, maybe they shouldn't be, but the conditional access policy doesn't have to change. If we have a user that is allowed to be an admin when they want to, well, then when they're an admin, they can't get into the applications that we don't want admins in, right? When they expire their admin account through privileged identity management, conditional access lets them right back in because they are no longer an admin. So the goal with defining these is to get to a point where we have as few controls as possible to give us as much control as possible, if that makes sense. And then we can look at the result of how that's going by looking at our sign-in logs. And there's actually a sign-in logs button here in the conditional access page that is a link to the Azure Active Directory sign-in logs with a couple of little guardrails and constraints around it. It ties it down to a longer sign-in period than what you would get if you go to the Azure AD Blade and look at sign-in logs. But what it's going to give us is, all this great information about each and every authentication. I get basic info about this user, location data, device, authentication details. And the first is going to show, the first of the conditional access spaces over here, both conditional access and report only, is going to show us which controls were applied directly to this particular authentication. So these conditional access policies were enabled and whether they applied or not, what the grant control was. I can click on any one of these and get more information about what attributes it matched, which ones it didn't. But I can also look at my policies that are only set in report only mode. And I can see in a separate view what is going to happen to this user's authentication if I were to turn this policy on. So in this case, I have two policies that would not have been applied because their conditions were not met, and one that would have been applied if it were enabled because its conditions were met. And if I click on that policy, I can see why it would have matched. I get a listing of all the conditions and actions and their state for this particular sign-in. And it's probably worth noting that there's really no way to do this in reverse. One of the questions that we get regularly is, how am I going to know which authentications this policy is going to protect, right? So I cannot, for instance, go into the policy itself and get a report of the sign-ins that it affected. And I've seen where this has tripped people up, because it makes sense that you would think that you could define this policy and see what its net impact would be, but you kind of can't do that. And if you think it through, it will make sense, because what you would then see is only the impacted authentications. And really what you want to do is you want to know how this is going to impact authentications overall. So if you've defined a very narrow range for things and you're not triggering hitting the triggers, it's going to look like it's not doing anything. So what you really want to do is you want to be able to go and look at your authentications overall and see what impact you're having to your global user base, right? Because it would be pretty awful if you created one, didn't see a whole lot of results, thought this is great, and it ended up blocking hundreds or thousands of user authentications. So a better way to come at that data is actually to look at the conditional access overview page. There's also an insights and reporting page, which we'll get into in a second, and they give fantastic high-level views of what apps are being used, what percentage of data is being protected, and even policy recommendations with ranked severity and links to actual impacting events in the sign-in logs. And then we get this really cool, nifty little view that breaks down conditions detected in the past 24 hours. And while much of it here is what I would consider to be low fidelity content, it is actually a great way to keep tabs on like device type distribution, apps that users are leveraging. And if you have users showing up in that dreaded unknown location right here off the southern tip of the world, you know that your value of your IP address location data isn't super great, right? So it's a great way to understand what is actually coming into your environment. Are we seeing a lot of managed devices coming in? Because if they are mostly managed, well, I can actually trust a lot more of this content at that point. So what should be the things that we focus on when we're creating and managing with conditional access policies? What I said before was we want to do the most management with the least management, right? By far, the biggest single issue that we see with CA policy deployments is sprawl. This is equally common in endpoint manager configuration profiles and Active Directory group policy objects, but largely reflects shifting priorities and poor documentation over time. And I've seen environments that had 3 or 4 or 5 identical policies in various states of enablement, but wildly different naming conventions. And I've seen tenants with dozens upon dozens of policies where neither the admins nor the management had a firm handle on what was even the intended result of the policies. So we get folks in there with great ideas. They may be an application owner. They ask for a policy or two. It gets out there, it's tied, and it just snowballs. This often comes down to issue number 2 that we run across, which is poor documentation, right? Honestly, there's nowhere in a conditional access policy or the blade to document the purposes of your policies. There is no description field, right? All you get is the name, and you can put a lot of data in that name, but then it's going to get truncated in the view. So there is no tagging, there is no document in place option that we have in a lot of other workloads, but that doesn't mean we're off the hook for documenting it. In fact, there's even this PowerShell thing here that we can download our policies, but most of the content that comes into this is all in this truncated system string kind of stuff. So it's really not even a great capability that exists there too. Now, there is a recent addition to Sentinel, right? If again, we're tying in all these additional products, there's a recent capability in Sentinel that can track changes in CA policies, but that's only documenting the changes. It's not documenting the actual original purpose. So there are all these kind of threads to pull, right? Like if you're explicitly governing a single group of users with a CA policy, but if that group is dynamically calculated by user attributes, then you'll need some other mechanism to govern and document that as well. If they grant access beyond something nebulous like compliance, right, then you'll need to have a good solid understanding of how that compliance is being calculated and how to reset the values of that compliance calculation if the user goes afoul and can't get access, so that they can get back in as quickly as possible. CA policies by themselves cannot document their own purpose, right? So we need to have a greater understanding of documentation, where that documentation lives, and you got to stay on top of it. And this is a big part of what I often get called in to clean up. And that brings us to the third challenge, right, that we need to address with best practices. And this is usually the result of numbers 1 and 2 combined. It's testing. Either the organization got started and it sprawled, or there was no clear documentation of purpose or of implementation. But now we have no idea of how to test or refine our policies to achieve the desired result. In fact, a lot of times we don't even know what they're doing, right? They're just out there and they're running, and we look at sign-in logs every once in a while. Somebody gets interrupted. What ends up happening, though, is that we go from these beautiful policies that say you must meet all these controls to, well, somebody couldn't get in, so now it's got to be only meet one of the controls. Well, then we ran into a testing problem, so now it's going to just go into report-only purgatory, and it's going to sit there in that mode forever. And again, your goal is to have as few policies as necessary to deliver the best set of safeguards possible, pulling high-fidelity signals from your existing systems and augmenting where necessary with low fidelity data. So we want to have a good solid test plan. We want to document all of our testing scenarios. We want to make sure that we understand what the impact is going to be to all of these systems and make sure that we can get out the door as quickly as possible. And usually what we find is people go in thinking that they're actually testing 1 or 2 scenarios, and it's usually closer to 12 to 16 scenarios, right? Doesn't mean we always need more policies, but we need to understand exactly what's going on. And that brings us to the last bit, which is understanding dependencies. When we are building out these policies, we want to say, okay, well, we only want to allow access to Teams, but Teams is SharePoint, Teams is OneDrive, Teams is also Exchange. Teams also surfaces other applications into it like Planner. So, we've covered a lot about how we do this, but there is actually a best practice articles and service dependency articles that explain how down-level applications can be impacted, but when the user is trying to get in and maybe they've got access to the one thing but not the other. And we can look at this as actually in some cases being ideal, right? We've talked about limiting the access of a user who's at risk. So maybe they should be able to get into Teams, but maybe they shouldn't be able to get into Planner. Well, we can absolutely do that. But we also need to understand that if we just say Teams in general, our users may not be able to get into the applications that exist down level, or they may get error messages when they try to get into Teams and it's trying to pull their calendar, but it can't get it because that's an Exchange Online value, right? So we need to really understand what are the applications that we're trying to govern. What's the amount of access that we want to allow our users to govern? We want to limit the sprawl of our policies, and we want to document and test to oblivion and make sure that we are going to be out the door with as few policies as necessary. And then again, making sure that we're still leveraging those internal security controls that exist in our connected applications so that conditional access is just giving us better nuanced control into our applications and still allowing application owners to be responsible for managing access in their own systems. So, burned through it, happy to take any questions that you may have.
Awesome job, Adrian. I've got some good ones. I'm excited. All right,
fun.
Ready. First one. I see all these recommendations about blocking legacy authentication with conditional access, but couldn't I just disable those protocols?
You can, and in fact, you should. We don't find that's done very often, but I actually had this conversation with a Microsoft engineer on Twitter. He was being asked a bunch of questions too, and we were talking about it. And he said, "Why wouldn't you just do both, right? It's one thing to lock the door of your house, but it's another thing to also turn off the lights at night so people can't look through your windows and see what's in there, right? You should absolutely do everything in your capability to advance towards your goal of zero trust implementation. So yes, turn off legacy protocols, block firewall ports, but then also layer these things in on top so that you have more security, more safety, because maybe you remember to do most of these things, but maybe you forgot one protocol, right? And all of these non-modern authentication capable protocols are considered to be legacy authentication protocols. So forgetting one or misconfiguring one is going to leave you just as at risk as not having that CA policy. So absolutely do both.
Awesome. And so Linux is listed in the device platforms for blocking. Does that mean that more Linux support is coming? Linux, I should say.
Thank you, Christina. No, I don't think so, actually, with a caveat, right? So we have seen that Linux support exists in Defender for Cloud. Linux support exists in Defender for Endpoint as well. And it is an expressly added value in the device platforms field in conditional access. However, I have seen no indication at all that Linux support is coming for endpoint management and configuration in MEM. And again, we did cover the fact that the device platform field is an unverified field. So it's a totally self-reported attribute, and I don't really see that Microsoft is in a hurry to add more support for Linux in the device management space.
Oh, awesome. I'm kind of embarrassed I said Linux.
Man, me too.
I caught myself though. Okay, next one. Do CA policies have an order of precedence?
They do not, actually. That's a really good question. So in Active Directory, we managed group policy objects in an order of precedence, right? So there was I can't remember what the order even was, but depending on what OU you were in and what site you were in and what this, that, and the other you were in, you would get a whole bunch of GPOs assigned, and then they would also be listed at that level. So if you're in an OU that had 10 policies, you as the admin would have to choose the order in which those policies would be processed. Then it would go up the chain to the domain and to the site and to local policies defined on the machine. But everything had an order, and you had to fit the order in really, really, really specifically, or you get wild results. Azure AD is flat. The processing of configuration profiles in MEM or Endpoint Manager is also flat, with the general idea that most restrictive wins. And the same is true with CA policies. They are flat with most restrictive wins.
Ooh, okay, and so going off of that, so CA policies require 81 P1 or P2. Is there an alternative for accounts that are more like service accounts with limited licensing? This specifically impacts things like legacy authentication disablement.
Well, there is the ability to add service principals, and where we see the most value with that is in the authentication of enterprise connected applications. I would imagine that if we were looking at managing things like devices that need to log in to gain access, we probably need to look a little bit more granularly about how they're doing that. We really don't want to have any POP3 in our environment at all for anything ever. But that can have a licensing implication for those users themselves and how they're getting access to our systems. Incidentally, the addition of a single P1 license lights these capabilities up. So if you have to protect an application for whatever reason, and you need more than the security defaults, you can actually just add one license or cover just those affected users to make sure that they get the controls they need. But yeah, those capabilities don't really surface in the AAD basic space.
Gotcha. So I've got one more question, unless anyone, if you have any more questions, please drop them in the chat and I will read them. But I feel like this one really wraps up kind of the whole in our well. So I've heard nightmare scenarios of customers getting locked out of their Azure environment with CA policies. How do we prevent that?
Yeah, I've seen it. Fortunately, it doesn't really happen anymore. So it used to be that, and I showed you this when I was, in fact, let's talk a little bit about that, right? I'll show you right here. So if I go back to my CA policies, when I go to create a new policy, I can absolutely say all users. I can just say, let's just do all users, right? Don't lock yourself out, right? This policy will affect all of your users. Please don't do this, right? But I'm going to say like, no, dude, I've got this. I'm going to roll hard, and I'm going to say all cloud apps, and I'm going to get another notification right here that says this is a really bad idea. Please don't do this. And I'm going to set this as a blocked policy. And there we go. I've got this notification right down here. Don't lock yourself out. Now, this didn't used to exist. You used to just be like, cool, all cloud users, all cloud apps, just block it, right? And yeah, we've seen that. It's bad. What I generally recommend, though, and I think I did touch on this, all excludes always beat includes. So I actually have I generally recommend that organizations create a break glass group, keep that group empty, and we just add that group as a exclude to our policies, especially our super duper ooper schmooper restrictive policies, so that we can put a user in that group, bypass the policy, get back in the event of absolute disaster. Now, this is probably more relevant to organizations that are replicating from Active Directory, because you run into the question of, well, how do I put a user in the group if all accesses are restricted? Well, you can't, except that if your Active Directory is replicating to Azure AD, and this is an on-premises break glass group, you can still drive to the data center, log into the domain controller, and put a user in that group. It'll replicate, you'll get right back in. So still recommend some minimal bypass, something well documented, but not exposed. So you can get your users back in. But yeah, you still have this safeguard policy, and all the restrictions, all the notifications there, they have really limited the brunt of that risk.
I appreciate the warning label they've installed. They really are about saying you are breaking your environment.
Yeah, and incidentally, like that whole drive to the data center thing, we've seen that.
Yeah.
Get up in the middle of the night, you got a drive to do.
Oh, really is a nightmare scenario. So I'm not seeing any other questions in the chat right now. If anyone has any last minute ones, please feel free to drop them in. But Adrian crushed it as always. And thank you everyone for attending today. So you will receive a follow-up email with the recording to this webinar by tomorrow. If you have any more questions around the topics covered today, please just reach out to me. I know Adrian at one point, oh, never mind. Both of our emails are there. Reach out to either of us and we will connect you with either Adrian or an appropriate AE. Please be sure to keep up with us on social or check our events page for more upcoming webinars. And we also have webinar recordings. I'm going to include this in the email tomorrow, actually. We have webinar recordings of similar topics on our YouTube channel, which I need to be better about promoting because there's so much great content that, Adrian, you've covered on there. But so I will send that out as well. But I'm not seeing any other questions, so we will end this thing early. And I hope everyone has a great rest of your Thursday. And thank you so much for joining us.